Hi guys, welcome to Blockscout workshop. My name is Kirill, I'm head of research and an engineer at Blockscout. So if you haven't heard of Blockscout before, Blockscout is an open source blockchain explorer for EVM networks, rollups, hundreds of them. So the agenda for this workshop is just a couple of slides, why and what is Blockscout and why it's important to have something like that. And then we'll just go through different things you can use in this hackathon Blockscout for different APIs, contract verification, and most importantly, how to win money in this hackathon. What's our bounty? We believe it's the easiest bounty throughout this hackathon, so thank you for coming. Just, should be pretty easy to get a part of it. So a couple of slides about why something like Blockscout is very important to have it in the industry, in the space. So in the past couple of months and years, we have seen this rapid growth in a number of EVM-compatible networks, rollups, with the advancements in the rollups like OP Stack, Arbitrum, zkSync, and stuff like that. It's become super easy, super cheap to launch your own rollup, to launch your own EVM, and then there are just multiple rollup as a service provider who does that for you with just one click of a button. You can get in a few minutes your own rollup for DevNet, testnet, or even mainnet purposes, and to use it for whatever specific app requirements you have, build your own app chain on top of it. And so in this scheme where you can launch your own rollup within minutes, it's really important to have also for each of those rollup, you need to have some interface, some block explorer to explore what's happening on this rollup, to explore your transactions, your addresses, the token movements, etc. And so it's really evident that no proprietary or closed source solution will be able to catch up with this open source movement. And so you won't be able to ever launch a closed source solution in a couple of minutes, but you can do so with Blockscout. Maybe not in minutes, but in a couple of hours for sure. If you're doing it for the first time, you can launch the Block Explorer for your own newly launched rollups. Or there are also rollup as a service provider, or ourselves, we are providing the service as well for hosting the open source Explorer for you. So what's the state of Blockscout today? Blockscout is the #1 most used open source, not just open source, but most used the Block Explorer in the number of networks. It's really hard to keep on updating these numbers because the networks are getting launched and turned off each day in tens or even hundreds. And so what's just some bullet points about the Blockscout success in this landscape. So Blockscout is fully open source on the backend side, on the frontend side. It's fully compatible with all of the popular rollup families like OP Stack, Arbitrum, zkSync, etc. It's fully compatible with the EVM, mainnet, if mainnet L1 specification. We have a bunch of different modules like ENS support or different other ENS fork support on different networks, depending on what's important here and there. We have some specific modules for supporting account abstraction, for supporting data availability and blobs, and a lot of different other modules you can turn on and off within the Blockscout instances. Blockscout is user-friendly, it's simple to use, it's very natural, and especially when you see it on these hundreds of networks, users are becoming very familiar with its interface, so it's becoming easy to just use Blockscout in the new networks as well, because you have seen it on the past in other networks tens of times already. So now about what we have for the hackathon. So basically, okay, let's talk through the Blockscout APIs that you can use for the hackathon, which is basically one of the ways you can apply for a bounty. We have, I think I should have a separate slide. Weird, okay. So yeah, we have a bunch of different APIs for the Blockscout you can use within your builds. One of them is the REST and GraphQL compatible APIs. So that's the API itself that is powering the open source Blockscout UI. So whenever you see something happening in the Blockscout UI, like different transaction information, block info, token transfers, or account abstraction data, that's the same data can be extracted through this UI specification. We have all the docs, of course, in the Swaggers, so you can search through them. And so if you want to get some specific part of the Blockscout data you can find in our UI. You can also incorporate it easily within your builds as well, just by finding the respective method in the REST API and use it right away. And the same stuff applies for the GraphQL, which is just slightly different format from the REST API standard. If you're more familiar with it, you can simply use it as well, no problem at all. Then the second piece of the API we have at Blockscout is an RPC-compatible API, which is designed to simplify the transition to Blockscout from other potentially closed source block explorers like EtherScan or other. So here we have this bunch of different modules. Basically, it's the same API as the REST API, but it's in a different format, which is fully compatible with the EtherScan or other closed source block explorers. So if you have some library that you are using for the block explorer interaction to fetch some data, to do something, to find some information, or if you already have some code interacting with the Blockscout through interacting with the block explorer by using some sort of this API, you can just replace the link with the specific RPC-compatible API from Blockscout, and it will be fully, it should work as good as on any closed source block explorer here as well. And then the other solution we have at Blockscout is then basically a JSON RPC-compatible API. So if you're familiar with all the methods that are available on the low level of the JSON RPC of the particular EVM node implementation, then you pretty much get all of this method for getting the logs, balances, transaction data, block data in the JSON RPC format. And these APIs are typically available through the dedicated JSON RPC providers like Infura, Anchor, Alchemy, or something like that. But we at Blockscout also are able to use our own infrastructure for hosting this data, and we are actually trying to expose the same data through the same compatible API as well. And the best use case for it, and also the way how we use it in our own UI, is as a fallback option for the existing JSON RPC provider. For example, here you can see the example for the popular WAGMI UI library, basically how to configure the fallback provider between multiple RPCs. You can put your injected wallet, then some public RPC provider, and if something happened to both of those, in the end you can also put the fallback provider to the Blockscout so that your API and your UI are more robust, more redundant, are available regarding of what's happening on the network level. Then a bunch of other stuff we have at Blockscout is related with the contract verification. So just contract verification is, of course, a really important topic for the developers, and it's a really important topic for the security perspective of the EVM space. So just to give you a few words how the contract verification works in general, is that whenever you're trying to match a certain deployed contract that is currently unverified, you are submitting the source code that you used originally to deploy this contract, and we recompile it on our own infrastructure with the specific compiler settings you choose, like the version, optimizer settings, specific library addresses you used. And then we basically match the bytecodes together, and if we get a 100% match, then we just put this screen tick in the block explorer and put the source code, and then you're able to interact with the contract through the ABI and the read and write contracts, and review the source code for your own contracts or the contracts verified by other on-chain users. So in Blockscout, the way it works is that in many cases, we can also automatically import the source code from different third-party platforms if the contract is already verified. For example, if we are able to match that a duplicate contract with the same source code, with the same bytecode already exists on the same Blockscout instance, there is a good chance it will be automatically matched and verified without any user action needed. Then we are able to do the same with Sourcify and the shared Blockscout bytecode DB database, which is sharing this bytecode and source code information across different Blockscout instances. So if you're able to find the already verified contract on some other Blockscout instance or on Sourcify, there is a good chance it would be automatically imported without any manual source code submission requirement. And then one of the other features we are currently working on is called the Verifier Alliance, which is basically a step above on top of this Blockscout bytecode database. And there, the idea is to connect not only open source Blockscout instances we are hosting somewhere, but also to invite and connect other source code providers like Tenderly, other block explorers, or different analytical tools where you have here and there different forms for submission of contract source code. Here, the idea is to combine them in a single database in a uniform format. And so whenever a contract is verified somewhere, it's immediately getting available for interaction or for analytics in all connected partners and their platforms. So if you want to know more about Verifier Alliance, feel free to join the Telegram community for further updates on that matter. So if none of these automatic ways for the contract verification work, then unfortunately you have to do something through the CLI or manually through the UI to verify your contracts. So here we have a bunch of different ways how you can verify and submit your contract information to the Blockscout. Basically, they do the same thing, but in a slightly different manner and a slightly better in certain use cases. And so it's better to use some ways than the other for some particular use cases. So first, the simplest way, and it's probably the best way to do the contract verification for small and very simple contracts, potentially consisting of just one file with a few lines, or the best for the Viper contracts, which is a second popular non-solidity alternative for EVM contracts, is to submit the contract through the Blockscout UI. Just pick the settings you used for the contract compilation, like the optimizer runs the compiler version, copy-paste the source code, and click verify, and after a few seconds, the contract will go through. Then there is a way to verify it through the different automation and custom verification logic. If you have some custom deployment pipelines, custom deployment scripts, then you can incorporate the Blockscout API for the verification directly, so that there are API methods that you attach the source code exactly in the same way as you did in the UI, put all the compilation settings and just make an API call instead of clicking the buttons in the UI. Then one of my popular ways is to go through Sourcify, so you can verify the contract there. If it's not verified, and then automatically import it Blockscout. So that's also a quick way to get contract verified in multiple places at once. Then there is some third-party tools that support the Blockscout verification, like Catapulta, which is basically, I think, the best way to proceed with the contract verification. If you have some really complex deployments consisting of huge number of contracts across different chains, and you just don't want to do it manually, these tools make it easier and faster to just optimize this across different chains, explorers, etc. And the last is probably the most generic way to approach the contract verification, is to use our integrations with the Foundry or Hardhat, which I believe are currently two most popular developer frameworks for Solidity contracts. And so there, through just specifying a couple of CLI options and pointing the developer framework to the concrete Blockscout instance URL, it will be also relatively easy to automatically verify the Blockscout contract whenever you're using those tools to write the deployment or deployment scripts, basically. And then one of the other features we have at Blockscout is support for different proxy patterns. So proxy patterns is a very popular way to write and deploy contracts within the Solidity landscape. So we support this huge number of different standards. We support minimal proxies, different proxies based on the specific storage slot parameter, ABI method-based proxy, and diamond proxy, custom proxy implementation, for example, Gnosis Safe. So if you're using any of these proxy formats, it also should be automatically verified within Blockscout whenever you verify both the proxy contract itself and the implementation. And the Blockscout will link those contracts together and simplify how you can interact on the contract page with those kind of contracts. So now to the good stuff. So basically what we have for the bounty is our bounty is very simple, very straightforward. We just have this pool price of $20,000 for all projects that successfully use the Blockscout throughout their builds. So basically, if you just use the Blockscout as a way to link user to the Block Explorer for their transaction that they made through your DApp, to the contracts they interacted with, to their address profiles, or to something else, then you qualify. If you verify your contracts in the Blockscout and show it to us during the presentation, that also make you qualify. If you use any of the above mentioned APIs, like the REST, RPC, GraphQL, or just put the JSON RPC fallback API for the Blockscout, you also qualify. And also as an optional bonus, you can also prepare and submit your dApp in a dApp Scout marketplace, which is a dApp marketplace on the Blockscout. So this would just allow your dApp to be available to more users through the Blockscout marketplace. And then the most important stuff of all, you just need to show how you use Blockscout and how you incorporated it during your presentation to be 100% eligible.
So sorry, you need to meet all the requirements or one of the requirements?
It's important to meet one of the first three, and then, of course, to show it to us and to specifically clarify it in the project submission, how you use to show the screenshots, or even better to show during the live demo, then you can be 100% sure. And this bounty will be split among all of the qualified projects, so we have like 20 of them, then each one receives 1,000. Yeah, and as one more bonus of what happens with Blockscout after the hackathon, we're also starting up and booting up the ambassadorship program for Blockscout and recruiting different ambassadors for creating social media content, for representing Blockscout in your local communities, for participating in different events as part of the Blockscout brand. So if you are interested in something like that and you want to apply and potentially also earn some money for that, please fill out the form and we'll get in touch very soon after the hackathon with more details on that matter. So that was pretty much it. Happy hacking, and if you have any more questions, please feel free to ask.
Are you happy with using Elixir for Blockscout?
Yeah, so the question is, are we happy with using Elixir? Yeah, Blockscout is open source, and it's currently consisting of two main parts: the core backend, which is written in Elixir, and we also have a bunch of microservices written in Rust, and then the front end is written on Next.js and React. So, are we happy with using Elixir? I think, yeah, why not? Elixir is a kind of unusual language, of course, and you don't meet it a lot, and maybe for someone it makes it harder to contribute, but at the same time also it makes Blockscout unique, makes it interesting for a lot of developers to look through its code base, to learn something new. It's interesting to just, nobody wants to contribute to another JavaScript project sometimes, but when you see something in Elixir, that maybe makes it more interesting to you to contribute something. So yeah, I guess we are still happy. Yes, yes, sure.
Does the API offer labels to addresses? So can I see like if the address belongs to like Binance or like some Uniswap project or something?
Yeah, the question was about is API export, is the API display some information about the tags on the addresses? The answer is yes. We have the API and the microservice for tracking different tags related to the different addresses. We have an service responsible for linking addresses with the ENS and alternative name service providers, so you get those tags as well. But yeah, for stuff like Binance addresses, whenever something is labeled somewhere and we imported it, yeah, there is an API for that.
So is the service of Blockscout only if it's self-hosted possible, and is the self-hosting having some requirements on the system we have set it up?
No, there is no requirement to set up your own Blockscout or whatever. We have like these hundreds of hosted instances of Blockscout that are hosted. Some of them are hosted by us, around like 50 of them. Some of them are hosted by rollup as a service providers or other teams as well. So unless you're planning to launch your own rollup throughout this hackathon, then of course you can spend some time to launch the Blockscout and we can help you with that. But if you're using the existing chains, then there is no need to do that.
Okay, there are chains that you can just use the APIs.
Yes, yes, for most of the popular chains and rollups, Optimism, Mainnet, Testnet, Base, Polygon, every one of them has the Blockscout instance.
Okay, thanks.
Okay, I guess we are done. Thank you very much. Happy hacking.